Thank you, Rick. Appreciate that.
Quite welcome.
That could have been another disaster averted. So, I just have to do one of these all on my own then, you see, otherwise. The plan is we just go through the real basics of electronics. I thought we'll start with remote control, a bit of RC, talk a little bit about batteries, and we can use some of the little micro droids as an example, just to get everybody started. I think just looking around the room, we've got people at varying degrees of knowledge, so it's not all me. It's people just chipping in, I guess, as we go through. But by all means, ask lots and lots of questions. Don't be afraid of just sort of stopping the talk and saying, can I ask this, or if you're interested in a particular area, throw it out there and we'll talk through it. So
I got a question.
Yep, go for it.
When are you gonna create a GitHub?
I saw your post, John, on that. Yes.
I'll ping you about it every once in a while. It's all good.
I know. I'll give you an answer on that, John. I'll do it tonight. Okay? How's that? I've no idea what I'm doing with it, but I will do, and I'll stick some
It's literally just a place to upload your code.
Yeah.
And for version tracking.
Exactly. And I just stick it on the shared drive. I don't always indicate that it's been updated, so it'll take all of that pain away from me.
Yep.
Good question, John. Thank you. But yeah, I'll do it tonight. If it's not there tomorrow, John, then by all means, reach out through the internet with your clammy hand and grab me by the throat. Tell me to do it.
No, it's okay.
Okay, cool. So, as I said, we'll have a little bit of a play with some stuff. I've got a bunch of electronics, batteries, servos. I thought probably the best place to start is to start to talk about some of the basics of RC, controls, and we'll talk a little bit about some of the batteries. I've got some of the little batteries that we use in the micros. And apologies for those that have kind of a bit deeper knowledge. We will start right at the very beginning. So we'll talk completely about the very basics of batteries, the connectors, so everybody's starting, I guess, at the same point, if that makes sense. Again, throw questions in as we go through. So there's a couple of types of batteries, and what I'm not going to do is go through a huge amount of detail, because a lot of research and information obviously you can find on the web. But the ones that I've been using for the little micro droids have been these batteries, which a little what's it called, nickel NIMH batteries. I can't remember what they're called properly. And they're pretty good. They're a small form factor. What's really useful or quite good about these is they're very, very, very safe. So they're basically the equivalent to what you would normally have on your AA batteries and things that you would you'd put into small electrical devices. They won't suddenly burst into flames. They've got an output of about 6 volts or 4.8 volts, and this is dependent on the number of cells. So what they are is they're basically a number of batteries connected together. 4 batteries will give you 4.8, because each battery does 1.2 volts. Okay. This one's got 5, so 5 times 1.2 volts is 6 volts. So it's as simple as that, really. They're really cheap. You can get them off Amazon or whatever. They do tend to be mass-produced. One of the challenges I think that we've seen in the group occasionally on these, and I don't know how, I've never experienced it myself, but you've got 2 cables coming out of the batteries, and with any power source, particularly a DC power source, you've got a plus and a minus. So the red is always the plus, always the 4.8 volts or the 5 volts, and the negative is always the 0 volts. What we've seen with a couple of people on the group have said that they've actually, these have been the wrong way around on some of the batteries. I've not seen it myself, but it's if you get, this is a one gotcha, if you do get these the wrong way around, it can blow whatever you've got on the other side of it. So if you're connecting this through to a a receiver or something like that, if you get it the wrong way around, it can cause damage. So, and these are rechargeable. They come with, these particular ones come with a little cheap, just move the light across there a little bit. So I'm just some lights over there, so you can see things. Yeah, they come with a small USB charge cable that literally just plugs in, and then you can charge them up with any USB socket in the simulator, what you would do with a phone. Now, one of the challenges that we've had with these and the RC connectors is, if you look on the RC connectors, you've got these what are called DuPont connectors, the small square connectors, and the ones that come on the batteries are the clips. So the first gotcha that everybody seems to be sort of a challenge with, which is how would you actually, you know, connect these two things together, because the different connections, they don't just plug in. Now there's a couple of ways around that, because all you're really trying to do is get these cables into something that you can plug into that. The first thing, the easiest thing, to be honest, is if you grab a servo connector, you can literally cut the end off the servo connector, which will give you something that'll plug into the receiver. And then what you can do is you can solder on the other end of the connector, so that you've got a small connector, if you like, that connects from this to this. The alternative is you just chop the end off here and you crimp another one of these onto there. But we'll get onto some of the connectors a little bit later on. So the batteries always give us DC power, and most of what we do tends to work on DC. At the other end of the scale, we've got these type of batteries, which are the LiPos. So these are, and the difference is these can run for quite a while. They're quite lightweight. They pack quite a punch when it comes to a battery, so they can output a lot of power in very short bursts. But unlike these are rather dangerous if you handle them in the wrong way. And it's important. These are, if you're going to do anything with LiPos, just have a quick look on YouTube or whatever and watch what happens when LiPos go wrong. I don't want to scare everybody off, because I mean I use these on most of the bigger builds and some of the like the DOs and whatever, but they do need to be handled correctly. If these get pierced, so if you stick a knife through these or whatever, or they're left connected to power for too long, they can actually sort of burst into flames. And I think we've seen a few pictures of sheds and whatnot that burnt down through incorrectly handled LiPos. Does that all make sense?
And you do need to make sure to be careful with them, letting them get too charged down too. Yeah. So there's and that's another important point. With these, you can literally run these down up until the point when they're completely out of power, and then you can just recharge them without any concern. A bit like you would do with your, any other sort of device. With these, there's a lot of, if you connect these into a standard RC circuit, there'll be a protection for these batteries that won't let it run below a certain voltage. Because when these get right down to nothing, it can mean that the batteries themselves are unrecoverable. So if the voltage drops and discharges to the point where there's no charge in these things, you can't recharge them at all. So you always want to kind of keep them. There's a storage charge as well that you keep them at. And I'm not going to go in massive details on LiPos, but it's definitely worth having a little bit of a Google on them. Cool. Anybody want to add anything on LiPos, or anybody had any weird experiences with such things? Just as we've all been in lockdown, if you've got LiPos, this is just a reminder to charge them up periodically. As Michael pointed out, I let one sit for too long, and yeah, it was trash.
They do. There's small little connectors that you can get that you can plug onto this bit. The way there's two connectors on the LiPos.
this is your main power that powers all of your circuit, and then this is a way of monitoring the voltage that's inside each of these cells. What you can buy from eBay, Amazon, is a small voltage checker that kind of sits on there with an alarm. So if you're running this on one of your own models, or using it for something that hasn't got a built-in battery protection in it, that little alarm will just monitor it, and if it drops below a certain voltage, it'll actually start to let you know about it. Okay, so very, very basics on batteries. Is everybody comfortable with that? Is there any questions before we move off power?
Can I ask a quick question? I'm just curious, how do you know how much battery you need? I mean, how do people decide that?
That's a good question. So on the batteries, the ratings on the batteries, if you look on these, they've got there's a 20. This is 2200 milliamp hours, and so batteries will come in. There's a couple of numbers on batteries. One is the voltage, how much voltage is it kicking out. The other one is this milliamp hours, and the milliamp hours is how much power is stored on that. So what you can do is the larger that number tends to be the larger the physical battery, and the longer the running that you've got of whatever you're actually running with it. I mean, I guess my rule of thumb is to try and get as much milliamp hours as I can get into a model, because then I know that it'll run, for a reasonable period of time within the space that I've got sort of allocated. So there's a couple of things on selecting batteries. One is what voltage do you actually need for your circuit. So if you're running logic, Arduinos, small circuit boards, will typically be 5 volts or 3.3 volts. And then the other consideration is how much current you're going to draw on it. So are you running big heavy motors? And I can't give you a simple rule of thumb, because what you have to actually do is calculate how much current you're going to draw, and then that'll tell you how many milliamp hours or how many amp hours that it'll actually keep it to draw through. But they're the two main considerations. Now, when you get into really complex models like the R2s and the whatnot, you tend to be running multiple voltages in the same system. So you'll have a 24-volt system or a 12-volt system, which will run off a 12-volt battery. But you'll also need a 5-volt system to run the logic that sits behind it. Now, again, what most people do is they will just run one battery at 12 volt, and then they'll have some circuits within there that will step it down from 12 volts to 5 volts so they can run some of the other logic, rather than having 3 or 4 batteries at different voltages that fits inside the device. But the general rule of thumb is work out what voltage you actually need, and then that higher milliamp hours you can get, the longer it will run without needing a recharge.
Thank you.
Cool.
Would folks that are not asking questions kindly mute? Michael, if you wouldn't mind muting those that aren't, that might be a good idea.
You're gonna let them back.
There we go. Everybody's on. I'll do it periodically. I just mute everybody, but that isn't to shut you up. That's just to keep the background noise so people can hear. But don't make me feel I'm all on my own. So if you do want to ask questions, fire in and just ask away.
Well, we do want to hear you.
Yeah, exactly. Thanks, Rick. So,
Michael? Oops.
Yeah.
I have a question. How do you know what BEC you need?
How do you know what, sorry?
BEC, to step down the voltage?
Okay, yeah. So these are your step down ones. The BEC or UBEX, whichever. For everybody else, what they are is they can take 12 volts and then they can step it down to 5 volts. Why I prefer these? There's a couple of different ways. There's all sorts of different voltage converters. You can get ones for little car converters that do 12 volts to 5 volts as well. why I like the UBECs or the BECs is that they've got a little bit of kind of battery management in there for lipos as well, so they will power off when you get through to a certain when you get below a certain voltage. Selecting UBECs. Typically, the reason you put them in there is so you can run a 5 volt or a 6 volt system, and most of them are switchable between the two. And so, in simple terms, you literally plug them into the 12 volt line with the plus going to the input on the UBEC and the negative going to the input on the UBEC. And the UBEC will actually kick out a 5 volt or a 6 volt consistent power supply that you can then use to power the rest of the devices. How you select the right one, generally the main thing that you're looking at is what ampage it will kick out. So some of the smaller ones will kick out, 2 amps or 3 amps. You can get them up to 20 amps, which effectively allows you to run more and more and more devices off that. So if you're just using that 5 volt, that UBEC to power, say, an Arduino, then any UBEC will do. They will power Arduinos quite happily, or pretty much any of your logic circuits. So that's just where you're powering small boards to kind of do things. Where you start to ramp it up is when you start to run lots and lots of servos off them as well, because servos, like any other motor, will tend to use quite a bit more power. So, and again, they're relatively inexpensive. So where I tend to do is I'll tend to overspec something. I'll put an 8 amp or a 10 amp UBEC, and 10 amps of servo movement is a lot of servo movement, because if you underspec it, what can happen is that 5 volts that you've got powering both your Arduinos and your servos, if the servos take too much of that current, the Arduino will just what's called brown out, which means there won't be enough power to actually power the Arduino, and then the Arduino effectively will do a reset. So if you're running a model and you start moving its head and you start doing a lot of servo stuff, it can literally just cause the Arduino to reset. So again, rule of thumb is I tend to try and go higher than I would do lower. But things like the BD1, which has got loads of servos in it, was running off an 8 amp UBEC. So the 8 to 10 amps are pretty overspec'd, I think, for the majority of stuff that we actually do. The other thing that you can do if you want to is run two UBECs. There's no harm in sticking 2 UBECs on a 12 volt supply and actually running two 5 volt supplies, one for your logic, which is your Arduinos, and then running the other one just dedicated purely to the servos. And then if the servos do get a bit giddy and start pulling too much power, it'll sort of reset, if that makes sense. It won't reset the Arduino.
Thank you.
I think the thing with these is once you understand the safety parts of it and the basics of it, it's okay to experiment and to see what kind of results that you get through that. There's a load of theory that sits behind this, and again, if you go through various articles on the internet, it'll tell you how to calculate actually how much load you're taking. Each of the servos will have their own individual spec. So if you wanted to take more of the scientific end, which is far beyond the basics of electronics that we're covering today, you can actually calculate it all, and you can get it all to specification. But for what we're doing, what I tend to do is overspec most things. We've got Trevor on. Trevor's quite clever on that kind of stuff, aren't you, Trevor? Yeah, he's just waving. But I know Trevor does lots of calculations, whereas what I tend to do is just overspec things. And again, as long as you know the basics, you're okay.
Overspecking doesn't hurt.
Yeah. It's when you underspec that's what hurts, isn't it, Trevor?
Often.
Yeah. Cool. Any more questions, and we move on? No. Cool. Okay, so so all your batteries. Well, so the general rule of thumb: one battery will give you power for everything that you need, and then what you want to do is just step down the voltage using whatever devices you want. UBECs are
my choice, but there are other sort of devices for smaller stuff. With the little micro droids or anything that you run off servos, you can run the whole thing on 5 volts or 6 volts. Just a little thing on the 5 volts and 6 volts. A lot of the remote control and RC setups will take various voltages. They're kind of specs. So I don't know if you can see this. This is a tiny little RC receiver off one of these little cheaper handheld controls, and that will take from 3.3 volts up to 10 volts. So that you can literally plug, a 5 volt power supply, a 6 volt power supply in, and that will work quite happily. And this is a little receiver off one of the Fly Sky ones that, again, a lot of the group use. This one will take from 4 volts up to 8.4 volts. So the tolerance on remote control stuff is pretty high. The tolerance on logic isn't. So if you power an Arduino, it's 5 volts. You can run some higher voltages into the Arduino to run it. There is specific connectors that let you run higher voltages, but typically all logic will run at around 5 volts or 3.3 volts. And again, it's in the documentation. So when you're doing small stuff that's got logic on it, I tend to stick to 5 volts because it keeps it really simple. I'm not going to start jumping up and down. What I actually like if I'm doing a basic RC one is if I step it up to 6 volts, I get a little bit of extra speed out of the servos, or I get a little bit of extra torque or power out of the servo because it's a slightly higher voltage. But I think we've done batteries quite comprehensively. One last thing on batteries is on the lipos. If you're going to start to use lipos, don't cut back on the charger. You're only going to buy one charger for all your batteries, and I see John shaking his head there. You buy the best charger that you can get. Your charger conditions your batteries, it charges your batteries, it'll last you pretty much the life of the batteries. So make sure you get a good one.
Absolutely. Spend the $50 or $60, get the Sky RC or whatever the equivalent is. It's that big blue box. Don't buy the $10 ones off of Amazon. They will kill your lipos. Ask me how I know.
How'd you know, John?
They killed my lipo. Actually, one killed my lipo and then died. And then I had one that I charged once and then the charger stopped charging. It didn't kill the lipo that time though. After that, I switched to the Sky RC or the Sky Max or whatever it is. It's the $50, give or take, whatever conversion rate. But yes, absolutely invest in a good one.
Yeah, it's quite cool. And you can get charging bags for these as well that effectively are fireproof bags that when you charge them, if for whatever reason happens, they go boom, they will stay in the bag and there'll be safety. So again, if you're going to use lipos, just check out the safety bits around that because it's well worth the investment on that.
You guys want a really, really good charger, this CI charger dual. They're quite expensive, but I've had this for 5 years now, and it's the best charger still in the market.
Yeah. It is a worthwhile investment.
Yeah, so I think it is. It's worthwhile. It's just you're only going to buy it once, so definitely. All right. What we'll move on to now is a little bit on the connectors. We've covered it briefly, but one of the challenges you've got is when you're starting to put all these things together, it's connecting them all together. Now you can buy pre-made connectors off Amazon with all of the ends on them, but I would highly recommend just grabbing yourself a set of crimping tools and a set of pins and learn how to put the ends on the connectors. Again, particularly what we do, it'll pay dividends. So if I look at this is a stock connector that's on there. When I've been doing the micro droids, I've literally just chopped the end off and recrimped another connector on. So this will go straight into the RC unit. So being able to do that, being able to make custom lengths of cables and whatnot is really, really useful. So I think I did a little video on crimping them. I mean, the tools are fairly simple. You've got a crimping set, and then you've got a bunch of connectors, and literally then you can get yourself any length of cable and make these connections up. Now, when you're starting to do this, particularly if you're crimping, say, this connector onto this battery, there's no way of switching this battery off, so it's live. It's live all the time. It's only like the equivalent of 5 or 6 volts. So it's not a lot on there, but you've just got to be a little bit careful that you cut it, you crimp one end, you put it into the plastic so it's secure, and then you do the same with the other end. But I would, as I said, I would strongly recommend you grab yourself a crimping tool, a set of crimping ends, and some cable, and just have a little bit of a play. I said there's a video, I think, on the YouTube channel that just shows you how to do that. But it gives you so much flexibility when you're starting to put these things together. And then likewise on the charger end, you can also do exactly the same thing. So you can crimp a connector on the charger end, and then you've got something that will connect to any RC device. Now, let's just cover because I think one of the other things that I get asked quite a lot about is the connectors on servos, or the whole connections really on RC. So we'll jump from batteries into some of the basic RC setups. So there's a couple of there's lots and lots and lots of options. These are great little cheap remote controls. You can get them in a number of channels. All the number of channels means a number of individual servos that you can connect to one remote control device. So this particular one is 6 channel. These can be 4 channels. They can be 2 channels. So this reduces as you go through. Now, the connectors that we use are a 3-pin connector, and you've got a 3-pin hole. And the challenge with that is the connector can go in that way, or it can go in that way. So it can go in 2 different ways, and they're not keyed, so you can put it in the wrong way. So you can get those, you can put them in either way. Now, the guys that invented servos and have thought about this, so you won't damage your servos and you won't damage your receiver if you do plug it in the wrong way. And the reason for that is on the 3 cables, what you've got is you've got a red, which is your 5 volts, you've got a brown, which is your negative, and then you've got orange, which is a signal cable. So that's the one that tells the servo where to move. If you get it the wrong way around, all you're really doing is mixing the signal and the ground cable up. The 5 volts is the one that you don't want to mess up with. So if you do get these things in the wrong way, the worst case scenario you'll get on a servo is the servo won't move until you switch it round. And the worst case you'll get with a battery is the thing won't power up until you switch it round, but you won't fry anything. If you get power on any of the outside pins, that's where you'll start to fry something. Because that's if you get power onto your ground or you get power onto your signal, that's where you can do some damage. But as long as you get the red cable into the middle, it tends to work. Now, the rule of thumb as to where they go, because unfortunately, a lot of the labels on these things don't really show you which of these pins is a signal and which of the pins is a ground. The rule of thumb I've always found is that the ground tends to be the one that's furthest away from the label. So if I plug that in like that, what I've got is I've got ground that's furthest away from label. I've got this orange pin that's closest to the label, and red's in the middle, and that's right. And it's the same on the Fly Sky. If there's documentation, and this one does actually have a little symbol that shows it in red, which you probably can't see on there, then obviously follow that. But don't worry about getting these the wrong way around.
Hey, Mr. B.
Yeah.
I don't know if you caught it, but I just joined the fire club.
I didn't know what happened.
I was messing with one of my converters from 12 to 5, and it was a little bit of a more past my knowledge, and apparently I hit the wrong button and it blew up. Caught a small fire, but went out quick. So that was fun.
You don't know specifically what went wrong, John?
I didn't know how to operate it.
Welcome
Okay.
to the family, brother.
Yeah, I figured it would be a different part that I blew up, but if you're recording this and you can see it, there's probably a pretty good reaction from me.
Yeah, well, the more we share of those things, the better, I think. We can see those. The less we do with them, the better as well, of course. Yep.
Anyways, I just wanted to add that I'll pay attention instead of messing with my electronics.
We'll play the recording back.
Yep.
Yeah. So because of that, so if you look at this, this is the one that I've recrimped the end on. What I've actually done is, even though there's two wires, I've put a 3-pin connector on there. And what I've done is put the red one into the middle. So the reason I've done that is so that, you know, if I'm ever wiring these things up blind drunk or whatever reason, I get it in the wrong, I can't actually get that red cable outside of, on the outer edges, it will always be in the middle. So again, if you're sticking connectors on it, all you do is just put a 3-pin plastic on there, and then you won't do any damage. Okay, so again, I'll just connect this one up. So there's the connector. The red goes in the middle. The black goes furthest away from the cable. This one will take power on any of these connections. It's a 6-channel connection, so I can just plug it in, and you can see there's a green light there to say that we've got power. They'll all have little LEDs on these little receivers. Here's another one. This is the Fly Sky one. This has got a dedicated VCC connection, which is the one at the end. And again, I just plug it in with the red in the middle and the black furthest away from the label. We can see there's a little red LED that flashes. So for the smaller droids, that's pretty much it. You're just trying to get your 5 volts into your RC. Okay. While we're covering that, I'll just now go through a little bit more about how our remote control of our RC works. So I've got this, which is a really, as I said, really basic remote control. It's got a power switch, light comes on, and then I've got my battery and the receiver, and I will plug it in as we said, which is with the black cable moving away from the middle. So you've got the red cable in the middle, and the black cable is furthest away from the label. And there we are. We've got a light now. These smaller ones tend to be pre-paired. So what that means is that they're straight out of the box. They're already connected. So you literally just plug a power connection into it, put your batteries in your controller, and now we've got something that will control servos. And so what I'm going to do now is I'm going to plug this, which is a servo, into it. And again, it goes the same way. The signal cable, which is yellow or orange, and the brown cable, which is your neutral goes furthest away. You plug that in, and then you've got your servo connected. So this is connected to channel 1. So as I turn it, now you can see it's working. So I mean, basically connecting or creating an RC circuit is really as simple as that. You just need a power supply that goes in. I think and again, shout out if you know differently, but on most receivers, you can apply power to any of the channels. Some of the receivers do have a dedicated power in, but you can literally put the power in on channel 3 or 4 or anywhere that's in there, and you still end up powering the RC circuit, and it works. The downside of these is it's typically this particular one doesn't support multiple receivers. So this will be for one model and that's it. So, you know, if you're making something as a gift for somebody, then by all means, you get yourself a cheap controller, get yourself a cheap, you know, full RC, and then you give that away. If you're actually going to start to build more than one model, I've made a few remote control models that are available to print. I don't know if you noticed, but what you're probably better off is getting a better RC setup that allows you to support multiple receivers. So we'll jump into the Fly Sky ones just to take you through those. So I'm not, you know, there's lots of different ones of these style, but you know, the one that we're using a lot of, I think, in the group at the moment is Fly Sky. Now these tend to be quite a bit more, have quite a lot more sophistication in the way that they control. This one is we'll do up to 10 channels. And again, one channel is one servo, so that's one channel, that's a channel, 2, 3, 4 channel, that's a 5 channel, that's a 6 channel, and then each of these switches is another channel, so 7, 8, 9, 10. So if you've got the right receiver, this will support up to 10 channels. It comes as default with a 6-channel receiver, but you can buy the 10-channel ones as well. And the biggest advantage of these is that you can actually set multiple models up in there. So the interfaces on these, they're not particularly intuitive, but you press the up and down key together and the cancel button, so 3 buttons together, he says, and it takes you into, there we go, takes you into the system setup. And I'll just quickly go in. So there's a system and there's a setup. If you go into the system, that's where you've got at the top of there. And again, I'm not going to go through everything in detail, but you've got a model select. And then what you can do here is you can select up to 20 models. So this one runs Dobby, DO, Tito, and Kit. So I've got 4 devices on there, and then you've got up to about another, I think it's 20 it goes up to, yeah. So I've got the option of adding 20 different other models to this. So to add a model is quite simple. You go to one of the ones that's available. So Fly Sky number 5. To set that as the default model, you press the cancel button, hold it in, which then saves it in there. And then you've selected that model. It won't let you switch the models while the receiver is live on the device. So you may have to make sure that your models are all powered down. So that's your number 5, and then you can literally buy as many receivers of these as you want and have a receiver in each device. So you don't have to take receivers out or move them around, if that makes sense. So the only thing that you have to do with it having these receivers is you have to bind it with the bind the receiver with the transmitter. And again, I'll just quickly talk you through how you do that. So this is the binding key, it's called. What this does really is you can see it's just a loop. It shorts the 2 outer pins together, so it shorts the signal to the ground. And on the little labels, you'll see that the top one's got a B/BCC, so B stands for bind. So all you do is you pop that little connector onto that top piece. That means then that now this a bit like when you turn your Bluetooth into pairing mode, it means that this is then ready to accept a new controller. You then apply power to set it red to the center, black furthest away, and when you do that, you've got a little flashing light on there waiting to bind. So you can pop that to one side, and then with your controller switched off, there's a little button here which is called the bind key. You can press and hold the bind key, you switch your controller on, and it will look for any devices that are ready
that are in that mode, and it will instantly bind to them. So it did that straight away. And the way you can see that it's bound is the top where is your transmitter. So it's telling me I've got 6.2 volts in there, because a lot of batteries are okay. And my model, my receiver, is now showing that as the lower one on there at 5.99 volts. So at that stage, these two are now bound. And again, if you look on there, you've got a little red light that's now not flashing, it's just continuously glowing, which means that they're bound together. What you've then got to do is remove the bind key. So otherwise, if you power it up again, it will effectively reset and start to look for another device. And now those two are now linked. So that model 5 that I've got that's in that menu, every time I select model 5, it will go to this receiver. Does that make sense?
Michael, FYI, I have had 2 of the 6 different receivers that I have from FlySky that came with defective jumpers for the pairing.
Oh, really?
Yeah.
Oh, that's I'm not.
Whether it was a batch, maybe it was a batch of bad crimps or whatever the case was, but couldn't get it to pair, fought with it for a while, went to get a known good jumper, and it paired instantly. So just heads up on that. Don't trust the jumper. If it's not pairing, try a different one, or at least check continuity.
Yeah. No, it's a good one, Rick. I've not come across that before. So again, similar, and there's no magic about remote about RC at all. You grab your servo, you plug it into your channel. So I put this receiver into channel 1, and then as I move the stick on the controller, it moves around. So that's interesting. I don't know what that's speaking of. Right, so I've got low power for whatever reason. So yeah, complete foolproof, nothing ever goes wrong. How interesting. I'm not that come across. Let me just try plugging the power in again, see what happens. Okay. Yeah, it could actually be that. It could be the battery. Say the battery's quite low, hence the beeping noise. We can check that. Let me just reasonable point. One of the things I mentioned, I think, on the session notes was one of the things that's really handy is a small multimeter, digital multimeter, just for checking such things. So I just got a message off the RC that started beeping, which said that the battery was really low on the receiver. So what I'm going to do is just very quickly check that with the digital multimeter. So, and again, you know, if you're starting to do lots of these builds, your digital multimeters are really handy for diagnostic purposes for when these kind of thing happens. Because what you can do is I'll just quickly check the voltage on across those 2 pins. Is I can check. There we go. I can check the voltage, so that's showing at 5 point. You can see that, but it's 5.7 volts on there, which is quite interesting. Because this is a new RC, new receiver that I literally just unboxed today. So yeah, that's showing it. That is showing at 5.4, so it's dropping down. So maybe the battery just needs kind of a recharge. Just trying to think if I've got any more batteries that I can lean on. I thought I'd recharge that one. Well, okay, so that's your RC setup. Any questions on RC, on either powering them, connecting servos, or just general usage on remote control?
Hey, Michael, can you hear me?
I can do, Andrew. Yep.
Yeah. So I'm new to RC. So when you plugged in the servo, the joysticks, like each joystick will move the servo in a particular direction. Is that how it works?
Yeah, absolutely, absolutely. So what you've got is with RC, you've got a number of channels. This particular receiver's got 6 channels. So channel 1 will be up and down. So if I plug the servo in and press that up, it will attempt to move to one end point. And I put it down, it'll move to the other end point and it'll center in the middle. Channel 2 will be that way. Channel 3 will be this other stick. Channel 4 will be this other stick. So each of these control servos independently, Andrew, if that makes sense.
Yeah.
5 and channel 6 is your little spinners. So again, they just control as you would expect servos to control. The switches are a little bit different. What the switches do is they move to predetermined steps within the servo. So if you switch a switch, it's not smooth. It'll just step from one place to another. If that makes sense.
Okay. So if I wanted to make, because I'm going to make my chopper, all my droids convert to RC. So when you want to make the droid move, how do you connect it to a particular motor or a motor driver? How does that kind of process work? I guess that's the part I'm confused on.
Yeah. So what you have is at the moment I'm using servos on these. So as I push that forward and back, it will literally move a servo to a step position. The other thing that you can get is electronic speed controllers. And what electronic speed controllers are is they've got the same connector on the end of them as the servos. However, they don't go to a servo; they go to another little board that you can connect a DC motor to. And so, what you have then is you'll have as you move the joystick up and down, that motor will either go faster and slower, or it may go into reverse depending what type of electronic speed controller you've got. So if you were to convert, so when I first built Chopper, I run Chopper on RC, and I use the Sabertooth 32 controller, which we use on the Padawans. It's a hefty old motor controller that will run the scooter drivers. And you can literally connect a receiver directly to the Sabertooth, and you can switch the Sabertooth into RC mode effectively, and so you can actually start to control it with the sticks on the RC controller, and the Sabertooth is then acting as an electronic speed controller. If that makes sense, Andrew?
Yes, that makes sense.
Yeah.
Yeah.
One of the things that I've not covered yet, so what we'll cover is the types of drive. So most of the ones that we build, R2, Chopper, a lot of the smaller ones, they use tank drive. We use the term tank drive a lot, and it's a differential drive. So, and this is one of the things that I wanted just to cover as we go through this is traditional RC controller. So if you think of a remote control car, for example, little like the Batmobile that John made or whatever, is you've got one axis or one channel that will connect to an electronic speed controller, which does your throttle or reverse, and then your other channel, your channel 2, you'll connect to a servo, which is connected to the steering wheel. So what you've then got is you can go fast back and forth, or you can actually steer through the servo. It's quite reasonably simple to set up. When we go to tank drive or differential drive, what happens is when you put that joystick forward, what you actually want is 2 servos to go forward at the same time. And when you pull it back, you want 2 servos to go back at the same time. When you go left, you want them to go in opposite directions. And when you go right, you want them to go into opposite directions the other way around, if that makes sense. And that's what tank drive is. Now, to do that, you have to do something called mixing, which is because what you're doing is you're mixing one signal or you're mixing 2 signals into 2 channels. And I guess that was one of it's on most of the instructions for the builds actually. But what you have to do is go into this kind of what's called
channel mixing setup on the device, which is on setup there. And if you just scroll down, you'll see mixes. And then what you're actually doing is you're doing a couple of mixes. Now on tank drives, the mix that we do on to get a tank drive is you do two mixes. You do channel 1 is the master and channel 2 is the slave. And what that means is that everything that I do on channel 1, which might be the up down, will actually have an effect on the left and right on the other servo. And so we've done this first mix, and then when it looks what you've got on lower down is then when the positive mix and the negative mix, so when it moves forward or when it moves back, and you set that as a percentage. Now tank mixing is there's two mixes we put in that kind of does tank mix. The first mix is where channel 1 is the master and channel 2 is the slave, and your positive and negative mix are both plus 100%. And then the second mix, which because the device itself will actually allow you to put more than one mix in there, your second mix then actually does channel 2 as the master, channel 1 as a slave, and minus 100 mix on the two. Now you can sit down with a pen and paper and work it through, or you can let yourself bleed out the ears, but that works on a tank mix, if that makes sense. So what happens then is as you push that forward, both servos move, etc. On the smaller RC, on the little trigger one that I've got here, that tank mix will be done with these little switches that you've got at the top, so it will support tank mixing. There's lots of different ways of getting that tank mixing done. You can do it on the controller end by using switches here or on here, or you can do it at the speed controller end. So the Sabertooth 32, for example, you can switch that into differential speed control mode, so it will still take the forward, back, left, right, and it's the actual speed controller that does that. But the chopper, when I've set the chopper set up for differential control, it is fairly straightforward. It's just some dip switches on the Sabertooth.
Okay, great, thanks.
Cool. Any more observations or questions on RC? On the setup? No. Cool. Is all this making sense? I mean, is this well? Camera's falling over. Is this kind of helpful to get everybody started? Yeah.
Yes.
Good. So what I'll do now is I'll circle back really then everything that we've done, and I'll just talk through the how this really then translates to what we've got with these little micro droids. Just take the head off, and I'm just rather than we've gone through the basics of power, the basics of RC. So I just want to kind of talk through what that means on some of the real. This is really a very, very sort of simple build for that implementation. So what we've got on the little ones is we have 3 servos, and I use servos for drive on these ones because a traditional servo, I think, as you saw when we were controlling this through the RC, will take a movement through 180 degrees and then it'll stop. So as you move the stick, the servo will match the stick. The servos that we're using on here are what we call 360 degree servos. So what they do is they just keep running a bit like a motor, but they still take a standard servo power and a standard servo signal. So when your stick is in the middle, the servo will be stationary. If you move your stick forward, the servo will continuously run forward, and if you move the stick back, the servo will continuously move back. And if you gradually move it to the center, it'll slow down. So you've got some degree of speed control. So what effectively using the 360 degree servo is a bit like having a mini electronic speed control built within the servo. So it acts as just a little mini motor, and it's a really simple way of getting the drive for these kind of little fellas, if that makes sense. So what I've got in here is very simple. I've got 2 360 degree servos. Now, the other thing I think that was mentioned is when you center these controllers, what should happen is these servos should stop. And what people have found is that they'll slowly kind of little edge around. So the motors, even though they're centered, will be moving a little tiny bit. And what that is really is it's a bit like trying to get the exact point in the middle that stops the motor. Now there's a couple of ways that you can adjust this, and again I know people mentioned it on the group, but most 360-degree servos have a little screw at the bottom, which you can get a tiny bit of screwdriver, and it allows you to change the center point where that servo actually stops. So you can the first thing you can do is you can put a screwdriver into the bottom of the servo and re-alter that little stop position in the middle. The other way you can do it is you can use what's called the trims on the remote control, and so underneath each of these axes you've got some little switches, and you've got a switch there, and what they do is they allow you to electronically shift where that center point is. So if I press that and I hold it in, you'll hear it. If you can hear that. So it kind of goes up, because they're drifting up, and then it beeps down. And what that's doing is it's moving the center point. So if I got a servo connected to that, the servo would gradually move back and forth. And if I got a 360 servo, the servo would gradually start to spin or to slow down. So they're called trims. And for each model, they're stored in the memory of this. So you can alter those trims to balance your device. So that if it is starting to creep forward, it will correct it. So on these have got they've got pots inside that you can alter, or you can trim it through there. But effectively, the circuit for these are incredibly simple based on what we've seen so far. So in here, the only thing I've got is the RC receiver. This is set up to one of the remote controls that I've got, and I've got 3 channels on it, which you can kind of see. 2 channels, channel 1 and 2 is for the 2 drives, and channel 3 goes to the servo for the dome. And these are all 360 servos, so that'll just spin round, and that's it for electronics. That's the whole connection done. And then the only thing that I need to introduce into that is a power source. So battery, and I know this battery looks like it's on its way out, but I'll plug it in anyway. And when I plug the battery in, that's where I get my little flashing light. And then effectively, all that happens is the battery sticks into there, your RC sticks in, and that effectively is everything that this needs in here. Now you can start to get a little bit more advanced if you wanted to. You could cut this main power cable here, and you could put a little switch in there so you could switch it off and on. I tend to just unplug the battery because the head flips in and out anyway. It just pops on the top. So that's my on-off switch. And then what you've then got on the controller is that particular model will be set up as one of the models with the tank mixing that we've done. And so it's really kind of for the little micros. What I wanted to put together was something that you could just experiment and play around with a simple little receiver that's running directly off the servos, a 5 or 6 volt power supply, and then the servo is just running in a very, very basic configuration and function. So let me just flip my video back. Yeah, so I mean, from a starting point, that's really pretty much what I wanted to cover off today. As any questions or any kind of, I guess, observations, what I'd like to cover off next as we start to move on is we've covered off really the basics of power and the basics of RC. I think next time what I'll start to then is introduce how we do a little bit more advanced power management. So we've talked about that today around introducing UBECs and stepping voltages up and down.
we'll cover off a little bit on things like fuses and switches, so you can add some extra bits in the in that first piece of power where you're not just got a 5-volt cable coming in. You've got a way of switching it on and off. Your fuses, which give you some kind of protection, and then we can start to talk on a little bit more around some of the logic stuff like the Arduinos and those kind of stuff. Michelle's just asked a question. So yeah, this is the FlySky FS-i6. Michelle is the one that I've been using. I think it was Lee Towsey, I think, who originally kind of suggested these, but they're really cheap but great kind of beginner's RC setup, and not particularly expensive. And I think this was about 50, 60 pounds, something like that. And these kind of cheap ones are around the 25 to 30. So you're paying a little bit more for these, but they will allow you to run a load of different models. The other thing that we're playing with at the moment, and Trevor's helping me out on this, is to try and get a small board that you can plug an Arduino Mini into, along with a Bluetooth connection, so we can start to run the little micros off a little phone app. So
that's exactly what I was about to ask you, because that's what I'm going to do, is use the little Arduinos, and I wondered if you thought it would fit in there.
Good question.
Because I haven't printed it yet.
Yeah. So what I started to put together was I've been trying to get a low energy Bluetooth dongle that would work with the iPhone, because some of the older ones don't work so well with the iPhone but work with the Androids. And there's a HM10, which is a lovely, just very, very small Bluetooth dongle, and there's an app called Dabble. So that's DABBLE. It's worth having a look at, Nancy. And what Dabble is, it's a really simple application that's got about 5 or 6 different controls on it. So one of them's like a joypad. It's got an analog joypad. It's got a little dimmer for an LED. And what Dabble does is it gives you a really simple library for the Arduino that connects all of that to an Arduino without too much programming. So if you, where I want to try and use it is for the little micros, which Trevor's very kindly helping me with, which is if we can get a little board that you can just plug an Arduino Nano into. You can plug a HM10, which is a Bluetooth module, and maybe a little DF player for some sound, and then it's a single board that's small enough to drop inside one of the micros that will give you sound, movement, and you can run it off the app on a phone. The other advantage is if you want to make these as like little gifts for people for Christmas and whatever, you're not having to buy all the RC setup, you're just popping those in and then they can use their own smartphones. But for schools and for kids to play with, it's a really nice setup, Nancy, I think.
Yeah, that's what that's why I wanted to explore that with the Arduinos, because I would be able to have the kids do some real basic programming, maybe make a couple of beeps, turn lights on and off, let it drive, things like that. But obviously I can't get, that many RC controllers and all that kind of stuff. So well, cool. Yeah, I'm interested to follow.
Yeah, have a look at that. Have a look at Dabble. What I'll do is, what I'm planning to do is, once we've worked out how we connect it all together easily, you can do it with wiring and making sort of harnesses up, but it's a bit more complicated. Whereas what we're trying to do, aren't we, Trevor, is just get a board where you can literally plug in a Nano, a Bluetooth connector, a DF player. And then once you plug that in with the right code on it, you can just connect your phone to it and start to do things. But for kids, it'd be great, because what they can do then is, the library is really simple. It's kind of, if the square button is pressed, do this. If the whatever, so they can start to configure it so that they can do different sounds, or they can do different things on very, very basic logic, which would be great. So the plan is that we'll try and get something that works on from a board perspective, so the hardware works. And then what I'll do is I'll do a kind of an idiot's guide or a simple guide to how Dabble works, so that kids can start to play with it and get a handle on the controlling. So fingers crossed.
Cool. That'd be awesome.
Yeah, no, it's quite exciting to do that, and I wouldn't recommend running, a kind of a chopper and an R2 full size on that thing, but I think for the smaller stuff that's not going to crash into people and kill people, I think it'd be all right. Fingers crossed.
I do have another question. Actually, it's one that Jason asked earlier. He was asking about how to charge the batteries when you've changed the connector. Is there an adapter available for that, or could you could make your own adapter, couldn't you?
Yeah, that's what I was saying before on these. So where you've chopped the connector off and you put your own connector on, you literally just do the same on the actual charge cable. So let's just see if I can go.
So, but if you didn't want to modify your charging cable, are you aware of an adapter that's available? Because I've seen adapters for, like other connectors and things like that, but I don't know about that little servo one for charging.
You can buy adapters. The part of the challenge with the adapters as well is making, because these style here are that you can't flip them round, so they're keyed so that they only go a certain way. Now, if you get an adapter cable, what I'm not sure is I don't think there's a international standard that says the red always has to be on the left-hand side, if that makes sense. So the challenge with an adapter cable is that you might get an adapter cable that physically clicks in, but the red might be connected to the black and the black might be connected to the red, depending how they've crimped them. So again, to me, what I've done as the easy solution is I've cut both ends off and always stuck to the rule of the red, the 5 volts or the 6 volts being in the center of a 3-pin connector. So even though we're only using 2 pins, the red's in the middle and the black's on one end. And it means then that even if I connect it the wrong way, as long as they're lined up, I'm not going to short anything across. And likewise, I can plug these happily into the RT controllers, and it's not going to damage them. But there's the options, I think. What's that, John?
Other option is just getting one of these little battery packs. If you've got a bunch of AA's floating around. Yeah. And I just put my own, but I have so many rechargeable AA's. You toss 4 of those in there, and you've got a 4.8 volt box as well. It's basically the same. I mean, it's the same batteries that are inside those sealed packs.
Yeah. Be careful you don't put any batteries in backwards.
Yep.
If you're cutting your batteries, don't cut them at the same time.
No, exactly. That's the only thing with putting these ends on is you are working on a live battery and you've got no way of stopping that. So I chop one end, I put a connector on it, I put it into the insulated plastic piece, and then I do the other end because you just don't want to short those 2 across. But as John said, these are just 1.2 volt battery cells, which is the same as AA's. So you can use these packs, or you can use the standard little plastic containers where you can put your batteries in there. So there is quite a few options. And use.
I like that one just because it's got an on-off switch.
Yeah. Again, lots and lots of options, but all you're trying to do is get 5 volts or 6 volts to the RC. Cool. Any more questions? Excellent. Well, thank you for putting up with that. What I'll do is I'll probably do the next one in about 2 weeks' time, similar to, I think we've got Drinks and Droids next week, and then we'll explore a little bit more on the advanced power. We'll shift from the micro droids up to some of the bigger ones. Then we can look at when you start to add things like UVEX and different voltages within the same circuit, as I said, with switches and fuses, etc. But thanks for that. If you've got any questions that you've come across these, then just ping us a message or dump on the group. As always, everybody's happy to help. But hopefully that was a good start. Yeah. On the UBEC thing, I'll go through that on the next one particularly. I can run it through on the kit actually, because I've got my kit here, which I can show all that fits together.
Cool. Right. Have a lovely evening, morning, afternoon, wherever you are. Speak to you all soon. And
Thank you, Michael.
thanks for popping along. Take care,
Thanks.
guys. Cheers.
Yep.
Bye, Michael.
Thank you.
Have a